The data-driven Nexus, how Flare and Google Cloud will redefine game development on the XRP Ledger executive summary. The convergence of the XRP Ledger's XRPL high-performance settlement layer with the Flare network's enshrined data oracles creates a novel and powerful technology stack poised to catalyze the next evolution of GameFi. This synergy, significantly de-risked and validated by Google Cloud's participation as a core infrastructure provider, establishes a platform uniquely positioned to host a new generation of data-rich, interactive, and provably fair games capable of attracting both independent and enterprise-level development. This report finds that the combination of these technologies addresses critical gaps in the blockchain gaming landscape. Flare resolves the XRPL's historical smart contract limitations, unlocking its vast liquidity and established user base for complex decentralized applications, dApps, like games. One Flare's enshrined oracles, the Flare Time Series Oracle, FTSO, and the State Connector, offer superior security, decentralization, and cost efficiency compared to the third-party Oracle solutions common in other ecosystems, as they are integrated into the core of the network's security model. The strategic partnership with Google Cloud, which serves as both a network validator and an FTSO data provider, provides a critical enterprise-grade endorsement. This collaboration enhances data integrity and instills a level of institutional confidence that is crucial for attracting major game studios. The technical capabilities of this stack directly enable novel gameplay mechanics, chiefly dynamic non-fungible tokens, DNFTs, whose characteristics evolve based on real-world data, and verifiable randomness, VRF, for provably fair in-game events. These features can serve as powerful differentiators for games built within the XRPL ecosystem. For developers, the ecosystem offers two viable implementation pathways: the XRPL EVM sidechain for ease of adoption and access to the vast Ethereum development community, and native XRPL hooks for superior performance and deeper integration. 12. This flexibility allows development teams to choose the architecture that best suits their project's needs. The strategic implication is clear. The XRPL Flare combination is not merely another GameFi platform, but an advanced infrastructure play focused on data integrity. This unique positioning allows it to capture a high-value niche of games that depend on trusted, real-time external data, a segment currently underserved by other Layer 1 and Layer 2 solutions. By solving the dual challenges of bringing external data on-chain securely and unlocking the liquidity of a major digital asset like XRP, this combined platform offers a compelling and differentiated value proposition for the future of on-chain gaming. The architectural duality, XRPL's efficiency, and Flare's data-centric design. The potential for a gaming revolution within the XRP Ledger ecosystem stems from a powerful architectural duality, the fusion of the XRPL's unparalleled transaction efficiency with the Flare network's purpose-built, data-centric design. This symbiotic relationship addresses the historical limitations of each platform, creating a combined stack that is greater than the sum of its parts and uniquely suited for the demands of next-generation GameFi. The XRP Ledger, a high-performance foundation for in-game transactions. The XRP Ledger, XRPL, is a decentralized public blockchain engineered for enterprise and business use cases, boasting over a decade of continuous, error-free operation across more than 63 million ledgers. Its foundational strengths make it an exceptionally suitable substrate for the high-volume transactional layers of online gaming. The XRPL's primary advantages lie in its performance metrics. It utilizes a unique federated consensus mechanism, which bypasses the computationally intensive processes of proof of work or proof of stake to achieve rapid transaction settlement in just 3 to 5 seconds. This speed is coupled with the capacity to handle thousands of transactions per second and transaction costs that are mere fractions of a penny. 17. For game developers, these characteristics are critical. They enable the seamless execution of high-frequency, low-value in-game actions, such as asset transfers, micro-purchases, or leaderboard updates, without the prohibitive fees or settlement delays that plague many other blockchain networks. Furthermore, the XRPL offers a robust set of native features that serve as out-of-the-box building blocks for game economies. These include a built-in decentralized exchange, DX, for asset trading, custom token issuance capabilities for creating in-game currencies, and multi-signing functionality for enhanced account security. 16. However, the XRPL has historically faced a significant limitation: the programmability gap. It was not originally designed for the kind of complex, Turing-complete smart contracts that are the bedrock of advanced DeFi and GameFi applications. 1. This meant that while the ledger was highly efficient for value transfer, its immense liquidity and large user base remained largely inaccessible to developers wanting to build sophisticated dApps. This historical constraint is now being actively addressed through two major initiatives. The first is the XRPL EVM sidechain, which integrates full Ethereum compatibility, allowing developers to deploy Solidity smart contracts within the XRPL ecosystem. 13. The second is hooks, a proposed amendment to introduce lightweight Layer 1 smart contract functionality using the efficient WebAssembly (WASM) standard. 12. This evolution transforms the XRPL from a pure settlement layer into a viable and compelling platform for complex game development. Flare and Songbird, the data and interoperability supercharger. Flare Network enters this picture as the specialized data and interoperability layer designed to supercharge blockchains like the XRPL. Flare is a Layer 1, EVM-compatible, proof-of-stake blockchain conceived from the ground up as the blockchain for data. Its core mission is to bring full smart contract capabilities and secure decentralized data access to non-smart contract chains, with XRP, Bitcoin, and Dogecoin being primary targets. A key component of Flare's development strategy is its two-network model. Songbird, SGB, serves as Flare's canary network, a fully operational, independent blockchain with real economic value. New features and protocols are first deployed and tested on Songbird in a live, unpredictable environment, allowing for rapid innovation and the identification of potential issues before they are pushed to the more stable and secure Flare mainnet. This model is highly advantageous for game developers, who can access and experiment with cutting-edge features on Songbird, gaining a first-mover advantage before they are available on Flare. The critical link between the XRPL and Flare is the Facets protocol. This system facilitates the trustless wrapping of assets like XRP into FXRP, a smart contract-compatible ERC20 token on the Flare network. The process is designed to be decentralized and economically secure, relying on a system of agents who lock collateral on Flare to mint FXRP, with the entire process being verified by Flare's native data protocols. For game developers, FXRP is the essential key. It unlocks the vast, dormant liquidity of the XRP ecosystem, allowing it to be deployed within sophisticated GameFi applications built on Flare's EVM-compatible environment. This relationship is not competitive but deeply symbiotic. The XRPL offers a highly liquid asset, XRP, and a massive established user base, over 6 million wallets, but has historically lacked the rich, data-aware programmability needed for advanced gaming. 30. Flare, conversely, was built to provide exactly this missing programmability and, more importantly, a native infrastructure for acquiring decentralized data, but it does not possess the XRPL's liquidity or long-standing market presence. Together, they form a complete two-way value proposition. Flare gains access to one of the largest liquidity pools in the crypto market, while the XRPL ecosystem gains access to the advanced dApp capabilities required to build a thriving GameFi sector. This strategic partnership is designed to elevate both ecosystems simultaneously, creating a powerful nexus for developers. Feature XRP Ledger, XRPL, Flare Network, Consensus Mechanism, Federated Consensus, Proof of Stake, Avalanche-based. 12. Transaction, speed, finality 3.5 seconds, 1.8 seconds, block time. 15. Transaction, cost, fractions of a penny, low-cost EVM transactions. Native smart contracts, limited, hooks via WASM, full EVM compatibility, Solidity. 12. Primary design. Goal, efficient value transfer and settlement, decentralized data acquisition and interoperability. 1 key asset XRPFLR, Flare, SGB, Songbird. 14. Interoperability solution, native DEX, cross-chain bridges, via amendments, enshrined oracles, state connector, F-assets. 15. Table 1, architectural comparison, XRPL versus Flare network, the data engine, Flare's enshrined oracles, and the Google Cloud Catalyst. The core innovation that Flare brings to the XRPL gaming ecosystem is its unique data acquisition infrastructure. By building two distinct Oracle protocols directly into its foundational layer and securing a landmark partnership with Google Cloud, Flare provides a data engine that is fundamentally more secure, decentralized, and cost-effective than those available on competing platforms. Flare's enshrined oracles, a foundation of trust. A defining feature of Flare's architecture is its use of enshrined oracles. Unlike most blockchains that depend on third-party oracle protocols like Chainlink or Pyth to bring external data on-chain, Flare's data protocols are integrated directly into the blockchain's core. This means that the task of providing data is performed by the network's own validators, and the security of the data feeds is backed by the full economic stake of the entire network. This enshrined design has two profound benefits for developers. First, it creates a more robust and decentralized security model. An attack on the oracle would require compromising a significant portion of the network's validators, a much higher bar than attacking a separate, third-party protocol. Second, it alters the economic model of data access. Because data provision is an integral function of the network, the data itself is treated as a public good, available to smart contracts without the direct, per-call fees typically charged by external Oracle services. This dramatically lowers the operational cost for data-intensive games. The Flare Time Series Oracle, FTSO, the network's real-time pulse. The Flare Time Series Oracle, FTSO, is the first of Flare's two enshrined protocols. It is a decentralized system designed to deliver continuous, high-frequency, and accurate time series data to on-chain applications. The architecture of the latest version, FTSO v2, is built for scale and speed. It supports up to 1,000 distinct data feeds, with updates occurring at block latency, which on Flare is approximately every 1.8 seconds. The system is powered by a network of around 100 independent data providers, who are also network validators. To ensure both efficiency and decentralization, the FTSO uses a sophisticated process. A stake-weighted verifiable randomness function, VRF, selects a small random sample of these providers to submit incremental price updates with each block. To maintain long-term accuracy and prevent drift, these rapid updates are periodically anchored to a full commit reveal process involving all providers every 90 seconds. This hybrid approach is highly gas efficient, as the bulk of the computational work is performed off-chain, with only a lightweight cryptographic proof, a Merkle root hash, being stored on-chain to verify the integrity of the data. While the FTSO is primarily known for providing cryptocurrency price pairs, e.g. XRP USD, its design is data agnostic and can be extended to any form of time series data, including stock prices, commodity prices, or even environmental data like temperatures. 4. The state connector. Attesting to external reality, Flare's second core protocol, the state connector, complements the FTSO by handling a different class of data. It is a decentralized protocol designed to securely prove the state of any external open system, be it another blockchain or a traditional Web 2 API, and make that proof available to smart contracts on Flare. 39. The state connector deals with deterministic, event-based data, e.g., was transaction XYZ confirmed on the Bitcoin network, rather than the continuous probabilistic data handled by the FTSO. The mechanism relies on a decentralized network of attestation providers. When a user or smart contract requests proof of an external event, these providers independently query the source system, e.g., a Bitcoin node, a sports data API. If a supermajority, over 50% of providers reach a consensus on the state of that event, the protocol confirms the proof and records it on the Flare network. This entire process is trustless and, crucially, requires no modification to the external chain or API being queried. Its use cases are vast, from verifying payments on non-smart contract chains to power the F-assets protocol, to settling on-chain prediction markets based on real-world outcomes like election results or sports scores. The Google Cloud Partnership, an enterprise-grade catalyst. The credibility and robustness of Flare's data engine were significantly amplified by the announcement of a strategic partnership with Google Cloud. In this collaboration, Google Cloud has become a full infrastructure provider on the Flare network, serving a dual role as both a network validator, responsible for proposing and validating new blocks, and a contributor to the FTSO, acting as a high-quality data provider. 5. The technical implications of this are substantial. Google Cloud's participation leverages its world-class, secure, and globally distributed infrastructure, inherently enhancing the resilience, uptime, and reliability of the Flare network. 45. As an FTSO provider, its contribution of high-integrity pricing data strengthens the accuracy of the Oracle's final medianized price feeds. However, the strategic significance of this partnership transcends the technical contributions. This collaboration is reportedly the first instance of Google Cloud participating directly in a decentralized, on-chain Oracle system. This act serves as a powerful, public endorsement of Flare's architecture and its data-centric mission. For enterprise-level game studios, which are often risk-averse when adopting new technologies, the presence of a globally trusted infrastructure provider like Google Cloud provides a crucial stamp of approval. It transforms the argument for Flare's data integrity from a purely technical one, our architecture is secure, into a compelling business and reputational one. Our architecture is trusted by Google. This dramatically lowers the perceived risk of building on the platform and is a key catalyst for attracting institutional confidence and investment. The partnership also includes Flare's integration into the Google for Startups Cloud program, which will help nurture and accelerate the growth of new projects, including games, within the ecosystem. Engineering the future of play, novel gameplay, mechanics on XRPL. The true potential of the XRPL Flare stack is realized when its foundational data infrastructure is applied to create novel and compelling gameplay mechanics. By providing a secure and decentralized pipeline for external data to influence on-chain events, this combined ecosystem enables a new category of data-reactive GameFi, where game worlds' assets and rules are in a constant verifiable dialogue with the real world and other blockchains. This moves beyond simple on-chain asset ownership to create experiences that are more dynamic, engaging, and trustworthy. Dynamic NFTs, DNFTs, creating living evolving game assets. Dynamic non-fungible tokens, DNFTs, are a significant evolution from their static counterparts. While a traditional NFT's metadata, its image, attributes, and properties, is immutable once minted, a DNFT is designed to change and evolve based on external conditions, with these changes being triggered by a smart contract. 10. The XRPL Flare architecture is perfectly suited to power these living assets. A game can issue an NFT on the XRPL or its EVM sidechain. A corresponding smart contract on Flare can be programmed to monitor a specific data feed from the FTSO or the state connector. When a predefined condition is met, for instance, a specific stock price crossing a threshold or a real-world sporting event concluding, the Flare smart contract executes and triggers an update to the NFT's metadata. The recent activation of the dynamic NFT amendment on the XRPL mainnet provides a native foundation for these mechanics, which can be supercharged by the rich external data feeds from Flare. This capability unlocks a vast design space for game developers. Evolving characters and items. Imagine an in-game pet whose appearance and abilities change with the real-world weather in its owner's city, with data provided by the state connector. An Ice Wolf NFT could become visibly larger and more powerful during a snowstorm. Performance-based digital collectibles. In a fantasy sports game, an NFT card representing a real-world athlete could have its in-game stats and visual Flare update in real time based on the athlete's actual performance, with data attested by the state connector. Economic tied assets. A virtual sword in a role-playing game could see its attack power attribute dynamically linked to the live price of a specific commodity like gold, with the data fed by the FTSO. Its blade might glow brighter as the price rises and dim as it falls. Community-driven content. The background of a piece of NFT art could evolve to become more complex or vibrant each time it is sold, or even mentioned a certain number of times on a social media platform, with the event being verified by the state connector via a Web2 API. Verifiable randomness, VRF, ensuring provably fair gameplay. A fundamental challenge in blockchain gaming is generating randomness that is both unpredictable and tamper-proof. On a deterministic system like a blockchain, naive approaches using on-chain data like block hashes can be manipulated by sophisticated actors. This undermines player trust in core game mechanics that rely on chance. A verifiable random function, VRF, is the cryptographic solution to this problem. It is a function that produces a pseudo-random number along with a cryptographic proof of its authenticity. This proof allows any observer to verify that the number was generated correctly and without bias, while making it impossible for anyone, including the game developer, to predict the outcome in advance. Flare's architecture is inherently capable of providing VRF as a service to dApps. The FTSO protocol itself uses a stake-weighted VRF to select data providers for its updates, demonstrating the network's native capacity for generating secure randomness. 4. A game built on the XRPL could make a simple call to a smart contract on Flare to request a verifiably random number for any critical in-game event, ensuring absolute fairness and transparency. Key use cases for VRF in gaming include provably fair loot boxes, guaranteeing that the distribution of rare and common items from in-game reward crates is truly random and not skewed by the developer. Unpredictable game worlds, powering procedural content generation for creating unique and replayable maps, dungeons, or enemy encounters. 11. Fair matchmaking in tournaments, randomly assigning players to teams or tournament brackets in competitive games to ensure unbiased matchups. Randomized NFT minting, assigning traits and rarities to a new collection of NFTs in a provably fair manner, building trust with collectors from the outset. Cross-chain and cross-reality experiences. The state connector's ability to attest to any event on any connected system unlocks the potential for games that transcend a single blockchain or even the digital realm itself. It acts as a universal data bridge, enabling deeply interconnected and interoperable experiences. Cross-game interoperability. A player could unlock a rare achievement in a game built on Solana. The state connector can attest to this on-chain event, which then automatically triggers a smart contract on the XRPL to mint a unique commemorative weapon for that player in a completely different game. 31. Real-world integration. An augmented reality, AR game could create a quest that requires a player to physically visit a specific landmark. A Web2 service like a location-based check-in app could confirm the player's presence. The state connector could attest to the validity of this API response, and the game contract on the XRPL could then release the in-game reward. Interconnected game economies. By combining the state connector with asset bridging protocols, developers can facilitate the trustless transfer of in-game assets and currencies between disparate gaming ecosystems, laying the groundwork for a true, player-owned metaverse where digital property is not siloed within a single game. The developer's blueprint, implementation pathways, and tooling. For developers and game studios looking to harness the power of the XRPL Flare stack, the ecosystem provides two distinct architectural pathways for implementation. This strategic flexibility allows teams to choose an approach that aligns with their existing expertise, performance requirements, and time-to-market goals. The choice between these pathways, the familiar EVM environment or the high-performance native hooks, will likely define the technical strategy for different segments of the XRPL GameFi market.